All right, class. Today we'll start chapter 9. So basically, you can think of this is the class for July 11. And in this chapter, we'll talk about different capital budgeting rules. So if you can remember from the last two classes, we talked about bond and stock. And I said that these are two important instruments for financing any project in the company or firm. So the idea was whenever any company decide they have to invest in fixed asset, they need fund and then they raise the money from the stockholders, bondholders. Now, assume that we have raised sufficient amount of fund to invest in fixed asset. Now, where we should invest? Should we just go outside and invest anywhere without thinking of the return, without thinking of the risk of this project? No, that's not. So in this class, we learn where we should make the investments. So basically, there are so many different proxies measurement that actually help us to decide where we should invest. So in finance, we call them capital budgeting decision rule or decision criteria. So let's say when you talk about different capital budgeting decision criteria, decision rule, we are talking about different measurement or proxy. And those proxies known as, let's say, NPV or net present value, NPV, net present value, payback period, discounted payback period, IRR or internal rate of return, and then modified IRR, and finally PI or profitability index. So I'm talking about net present value, payback period, discounted payback period, internal rate of return, modified internal rate of return, profitability index. So 6 different proxies, right? Now, when you have 6 different proxies, are all there good? All they're sufficient to give us the decision, should we invest in the project or not? Or one of the other is better than the other one? So when we have to decide whether the proxy we are using is good or not, we have to answer 3 questions. These are 3 questions. If all of these 3 questions answer comes out as yes, like when you're running any proxy or decision criteria, decision rule, and at the same time, we're also checking these 3 checklists. All these checklists are coming out as yes. In that case, we can say that this is the right proxy, and we should make the decision based on this decision rule, decision criteria, right proxy. Let's go over this decision rule or criteria. Does the decision rule adjust for time value of money? So far we have talked about 6 proxies, right? So whether this rule adjusts for time value of money or not. So when you say time value of money, that means if we receive any cash flow tomorrow, we have to discount it back today so that we can compare with today's investment with tomorrow's inflow. Make sense? So, or in NAV language, you have to think about if we receive or if we pay cash flows in different time periods, we have to make sure that when you are comparing inflows and outflows, we are adjusting for their different timing period. So basically, let's say next 2 years, we will receive some cash flows, but we have to make investment today. If we have to make the decision, should it be the right investment or not, we have to discount or we have to convert all the future cash flows today so that we can convert it to this investment so that we can consider their time value-ness in the cash flows, not we are considering them in the nominal basis, just not nominal basis. So we're going to explain more in detail. So what is time value of money? But if you can remember from chapter 4 and chapter 5, what we learned, same amount of cash flow in different time period has different value. So the basic answer is when you're trying to make a decision for any investments, we should consider that inflow today versus outflow tomorrow have different values because of the timing. So we should have adjusted for that. So that's the first thing. Does the decision rule, like these 6 things, adjust for risk or not? So what does it mean by risk? So every project has some risk in it. So basically, we are not going to talk about a lot of risk in this chapter. We're going to talk about a lot of risk in chapter, I think, 13, okay? So the idea is, so far what we learn, required return on bonds, we can get it from the market. On stocks, we learn in chapter 13, CAPM model to calculate the required return. So the definition or concept of required return is that when you know the riskiness of any projects, based on the risk classification, you should require a certain amount of return so that you should invest in the project. So let's say putting money in bank is not risky. So that's why you require 3% return to put money in bank deposit. Okay. Now putting money in stock market is a little more riskier than bank deposit. So that as a result, if it's more risky, stock investment should require more return. Let's say 7%. Okay. These numbers are hypothetical. Okay. Going forward, I'll tell you how to get this number. But right now, what I'm trying to tell you, this is less risky projects, you should require less return. This is more risky project, you should require more return. And we have to think about whether my project has a required return or not. If the decision rule we are following is using a required return to discount the cash flow, that means this decision rule is taking care of the risk. If the decision rule we are considering do not have any required return to discount the cash flow, that means that decision rule do not taking care of the risk. Does the decision rule provide information on whether we're creating value of the firm or not? If you can remember from chapter 1, we said that objective of corporate managers is to maximize shareholders' value, shareholders' wealth, stock price. So what does it mean by value? When you say about value, that means present value of all the cash inflow should be greater than present value of all the cash outflow. Let me make it easy and simple. So let's say you're thinking about to put $100 in a donut shop, okay? And the donut shop is offering you $110 next year. Let's say it's an investment, 1 year investment. Now, present value of outflow is $100, right? Now, if you discount your $110 for next year today, at your required return, I'm not telling you how much, at your required return, okay? And find the present value today, and then look at the difference. If the present value of $110 is more than present value of $100, that means you're generating value. In short, if present value of cash inflow is more than the present value of cash outflow, you're generating values for your project. So if the decision rule we're using is taking care of all of these 3 checklists, we're in a good shape. We should consider the decision rule as the best one, as our primary decision rule. Okay, moving forward. Net present value. What is net present value? You can think about difference between the market value of a project and its cost. Or in other words, in plain language, net present value. The definition in NAV language. Did you see the net present value? So, present value of inflow minus present value of outflow. Make sense? That is net present value. If NPV is 0, greater than 0, sorry, NPV is greater than 0, we can think about this project is generating value for the owners, shareholders, stockholders. Take the project. Equal to 0, indifferent. Okay, doesn't matter if you invest, doesn't invest, doesn't matter. less than 0, do not take the project, because if the NPV is less than 0, you are destroying the shareholders' value. That's an agency problem. Okay. Now here is the thing. If NPV is positive, accept the project. Okay. Here is the thing. Now project example information. Let's go through example. If you look carefully, you're talking about a project that's gonna last 3 years. Okay. Today you're gonna make investment. So this is your outflow, and this outflow is today. So that means this is the present value of cash outflow. Okay. Present value of cash outflow. Now, inflows, but they're in future, right? Year 1, year 2, year 3. So we cannot just directly compare these 3 cash flows with that, because they are in 3 different time periods. Now we have to convert all those cash flows to today's value and then capture present value between these 2 different inflows and outflows. Okay. Now let's do it in Excel, and then you can do it also in the functional calculator. So in the exam, I strongly recommend using the functional calculator. That easy, quick. It will save you time a lot. Okay. So I already inputted the raw cash flows. Now here is the thing. Forget about this one right now. Okay. Make it white. So if I compare this 3 cash flow with that, it may looks like I have 225,000 of inflow, whereas I have 165,000 of outflow. It's a good project. This is completely wrong. Okay, you're in a finance class. You're not in some basic math class. You're in a finance class. This is completely wrong. What do you have to do? We have to take back all of their values in today. How can you do that? Discount them. Now for discount, we need a discount rate or required return. Going back to the slide, 12% is my required return. So what I did, any cash flow today is the same present value, right? Okay. If you look carefully, 63,120 divided by 1.12 to the power 1, because that cash flow is at year 1, so we should discount it by 1 year. That cash flow at year 2, we should discount it by 2 years. That cash flow at year 3, we should discount it by 3 years, right? So now these all cash flows are discounted today. Now do the summation. So what you can do, present value of outflow is this much. Present value of inflow, all inflow is this much. Now look at the difference. Make sense? So do you think, give me 1 second, there is a typo maybe. Let's see. So here's the typo. The typo is, this is already negative, so I should do this plus this, because this is already negative. So 177 minus 165. So if you look carefully, present value of inflow is more than the present value of outflow. So we are creating value. NPV is positive. So what is the decision? Accept the project. Okay. Now, we also did the calculation here for your convenience. You can follow this. Now let's do the same thing on the functional calculator. Now here's the thing. So far we learned these 5 functions, right? N, I over Y, present value, payment, future value. So the idea is, if we have even cash flows, or if we have 1 cash flows, this is good. But if we have uneven cash flows like that, we cannot use these 5 buttons. Make sense? We have to use something different. we have to use these cash flow formulas. Now clear everything, we have to use these cash flow formulas. Your job is click CF, then clear, okay? Now CF0, that means cash flow 0, which is 165,000. Enter. Cash flow 1, which is 63,120. This is positive, okay? Enter. Now you have to be careful. Cash flow 1 occurs at year 1 for one time. So frequency is 1, okay? Frequency is 1 because it occurs at one time. Cash flow 2, 7,800. Enter. Occurs at year 2 for one time. Occurs at year 2, frequency 1 time. Cash flow 3, 9,1,080. Year 3, one time. Okay. So we have inputted everything, right? Okay. Nothing cash flow 4. So what you did? Cash flow 1, frequency 1, cash flow 2, frequency 2, cash flow 3, frequency 3. We are good so far, inputted that. Now compute. Did you see that NPV, CPT, NPV, it will ask for discount rate. Okay, I means discount rate. 12%, enter, scroll down, compute. Did you see that 12,627? Now you can think like you want to see it again. Let me do it again for you. Your job is second cash flow clean. Okay, second clean. First job, clean everything. Otherwise, it may end up wrong result. Second cash flow clean. Now go to cash flow button again. Cash flow 0 is 165 negative. Enter. Cash flow 1 is 63120. Enter. Frequency one time. Cash flow 2 is 7800. Enter. Frequency one time. Cash flow 3 is 91080. Enter. Frequency 1. Compute NPV. It will ask for discount rate. Scroll down. Compute. Easy. So here is my NPV. Positive. Accept the project. Now let's answer these 3 questions. Does it account for time value of money? Yes. Yes, because we are converting all cash flow in today, present value. Risk of the cash flow? Absolutely, because we have a required return. Required return captures for the riskiness of the project. Does it provide any indication about the increase in value? Absolutely, because we can see that there is an increase of $12,000 in value. So, what is the answer? We can use NPV as a primary decision rule. Okay. Now, second rule, payback period decision rule. Okay. Now, what is payback period decision rule? So basically, in payback period, it actually compares the raw cash flows, the nominal cash flows. They do not discount. When you say nominal, they actually compare the raw cash flow in different time period. They do not consider the present value or discounted cash flow. Okay. Now, what they do, they look at the raw cash flows and then they decide how many years it will take so that I can get back the initial cost in nominal basis or raw basis. So that is the prime payback period decision rule. What is the decision rule criteria? You will only accept the project if you have a predetermined number of years. Okay, so basically, you can say that if I can get back my initial cost back by 4 years, I should take the project. Or you can say that if I can get back my initial investment by 2 years, I'll take the project. Something like that. You have a predetermined set of number of years or months or time period. And if your raw cash flow is more than the initial cost by that time period, you can accept the project, else reject the project. Now for the same cash flows, okay? Here, okay? Same cash flows, forget about this one. Now let's do this way. Let's say year 1, year 2, and now year 3. So initially we start with 165,000, and end of year 1 we'll be getting 63120. So that means end of year 1 we still need 100,000, around $100,000 to be back from our initial cost. So basically we started with $165,000 of investment, day 0. End of year 1 we got this cash flow back, or still we want 101,000 from the project about our initial cost. Use that minus year 2 cash flow. So still $31,000 need to be back from the project. Use that. So now all of our initial cost is back and we get more than the initial cost. Now be careful, we are comparing the raw cash flows, nominal cash flows, okay? Now, let's say if we have decided we'll accept the project if it pays back within 2 years. If we decided, do you want to accept or reject? Because end of year 2, you did not get back your initial cost. End of year 2, you did not get back. You get back your initial cost in the middle of year 3. Reject the project, right? So this is payback period. Now, checklist. Does the payback rule account for the time value of money? No. Why not? Because we did not discount any future cash flows today. We just compare the raw cash flows. Account for the risk of the cash flows? No. There is no required return. Our required thing is a number of years, but there is no required return. Okay. Does the payback rule provide an indication of the increase in value? No, because when you talk about value, we have to compare present value of cash flows with the present value of outflows. We don't know that. We did not go through value creation activity. Should you consider the payback rule for a primary decision rule? No, we should not consider payback rule for a primary decision rule. No. Pros and cons, easy to understand. Don't consider time value of money, just go through the slide. Now, discounted payback period. So payback period, discounted payback period is similar. The only difference, discounted payback period, consider the discounted cash flows, not the nominal one, not the raw one, okay? That's the only difference. Now let's use the same thing. So all else same. So they will consider your initial cost with the present value of the expected cash flows, and they will look at how long it takes so that you can get your initial cost back in a discounted basis. And if that time period is within your required time period, take the project, accept, reject the project, okay? All else is same. The only difference for discounted payback period, we'll consider the cash flows in a discounted basis. Makes sense? Similar example, let's do like this. So this is our discounted cash flows, right? So let's do year 1, year 2, year 3, right? Start with 165,000. Then present value of the cash flow 1 is this much. So that means from that project, we still need $108,000. Start with this, present value of this much. Start with that, present value of this much. So what you can see, after year 1, we do not get the initial cost back on a discounted basis. After year 2, we do not get the cost back on a discounted basis. But after year 3, we got the cost back on a discounted basis, the initial cost back. So let's see, we still think 2 years is the required time period. Do you want to take the project back? No, absolutely not. We don't want to invest in this project because we need more than 2 years to get our initial cost back, okay? Because we are getting our initial cost back in the middle of the year 3. Make sense? Now some decision criteria, checklist. Discounted payback period, account for the time value of money, yes, because we are discounting all the cash flows in the present value. Riskiness of the cash flow, yes, because there's a required return. So from the NPV example, we decided the required return or discounted from this project is 12%. And I'm also using the same 12% here. If you look here, that means there's a required return. So taking care of the risk. Does the discounted payback rule provide an indication of the increase in value? No, because we are not comparing present value of inflow with the outflow. What we are comparing, how long it takes to get the initial cost back. Should you consider as a primary decision rule? No. Pros and cons, with pros and cons. Now, internal rate of return, also known as IRR. So you can think about IRR is basically a rate of return or discount rate we are calculating so far. Like from chapter 4, we calculated the rate, right? R. Chapter 5, we calculated the rate again. And then I think chapter 7. No, I'm saying it wrong. From chapter 5, we calculated rate. Chapter 6, I calculated rate. And chapter 7 in the bond, we calculated yield to maturity. And yes, so this basically all is rate of return or IRR, okay? Financial calculator, this is the IRR, okay? So now, so the idea is in IRR, we do not use the explicit required return on 12%. What we do, we try to calculate the internally generated rate of return. So what we're gonna do, we will input the cash flows, and then calculate the IRR. And if that IRR is greater than the required return 12%, if that IRR is greater than required return 12%, then only then we will invest in the project. So accept the project, else reject the project. Make sense? So now the same problem. So here, if we go to cash flow 0 is -165, cash flow 1, frequency 1, cash flow 2, frequency 2, cash flow 3, frequency 3, compute IRR. Did you see that 16.133? So if you do compute IRR, then compute, you're going to give it 16.1322. So this is the IRR from that project. Make sense? Now, our discount rate for that project was 12%. Discount rate for the project was 12%. It's more than the discount rate, so accept the project. Now, checklist. IRR account for the time value of money? Yes, because IRR actually gives you internally generated return that compares outflows with the inflows in a present value basis. So when you say IRR, it means it's a return that actually equals all the outflows with the inflows on a discounted basis. So it takes care of the time value of money. Risk of the cash flows. Explicitly, IRR do not consider the risk of the cash flows because we do not input the 12% required return on that. But think carefully, when we made the decision, we said compare IRR with the required rate of return. If IRR is more than the required rate of return, then only accept the project. So in that case, implicitly, we are actually taking care of the risk of the cash flow because we are comparing IRR with the required rate of return, then make the decision. So yes, implicitly yes. Now, increase in value, absolutely. Why? Because IRR is telling you some internally generated return with the required rate of return. So if IRR is more than required return, your NPV should be always positive. So that's scientifically proven. If IRR is more than your required return, NPV should be positive. So that means value creation. So the thing is that IRR takes care of all of these three questions, and the decision rule, should we take this IRR as a primary decision rule? Answer is yes. So, summary. What you learned so far? Which one should be used as the primary decision rule? NPV, yes. Payback, no. Discounted payback, no. IRR, yes. Now, the next two things, modified error and PI, these are extension of. Modified error is an extension of error. PI is an extension of net present value. So you cannot think those are very core decision rule, but they're extension of existing decision rule, okay? So in the next class, we'll talk about that. But before that, let's have a quick overview of the homework, okay? Now, homework 3. State capital budgeting decision criteria. We talked about that, so it's basically here. The capital budgeting decision criteria are these 3. So these are basically these 3. About this problem, we did it today. You're receiving a new project and have estimated the following cash flows. So these are basically here. NPV is basically here. So that's all for today. In the next class, good thing gonna be we're gonna finish this chapter. Okay. See you all in the next class.